I am John Merrill, General Chairman of this 20th EEIC ICWA exposition held here in Boston. The 1991 winner of the paper judged to be of lasting interest is titled Power Capacitors by G. Newcomb and S. Chianowski, General Electric Company.
The power capacitors that I will be talking about today are AC high voltage types that are typically used by electric utilities on their distribution lines for power factor correction. They are also purchased by industrial concerns in order to balance out the inductive loads of their machinery. The development of the dielectric materials for power capacitors can very succinctly be shown on one slide. Power capacitors were first developed or manufactured in about the 1920s. At that time, the materials that were used were mineral oil and natural paper. The paper dielectric has been with us, or with the industry, for some 40 years. On the slide, you'll notice that what we're plotting are watts per kvar versus dielectric temperature. These curves represent the internal losses developed by our dielectric systems as they operate. The watts per kvar represents the electric energy dissipated in the capacitor per energy stored per cycle. It is the objective in the development of dielectric materials for capacitors over the decades to lower and lower the watts per kvar. For decades, paper has been the dielectric system. Capacitor manufacturers and capacitor paper manufacturers spent quite a bit of time improving the quality of their paper in order to reduce this internal loss. Various processes were invented. The Kraft process, which was a very important step forward in removing objectionable organic components of the paper in order to remove them from the paper and therefore reduce their contribution to the internal losses of the dielectric. In the early 60s, the capacitor manufacturers and the capacitor paper manufacturers had essentially exhausted what they could do with this particular dielectric material. And it was at that time that the synthetic polymer industry was beginning to emerge. Researchers at capacitor manufacturer plants and in the film processing industry began to look at various types of polymers that could perhaps take the place of paper and improve the properties one would require for high voltage AC power capacitors. In 1965, there was a major advance made in the dielectric materials for power capacitors. It was in that year that the system, the mixed system dielectric system of a polypropylene synthetic polymer with paper appeared on the market. As one can see from the graph, there was a dramatic reduction in the watts loss over our temperature range of interest. The polypropylene film is an inherently low loss synthetic polymer, which I will say more of later in this talk. Capacitor manufacturers, realizing that the polypropylene was doing this for the system, obviously began to think about what are the possibilities of going to a completely all film or all polypropylene capacitor system. And in fact, that is the case. And at the end of the 1970s, the all film polypropylene capacitor appeared on the market, and one can see that there's a tremendous reduction in the internal losses for this particular capacitor. What does this mean for the customers? Why do we do this? Why are we reducing these internal losses? Well, the main reason is if we reduce internal